Okay, so welcome everybody to today's USW Exchange webinar, R&D support with the Centre for Photonics Expertise. We're running this event today as part of a three-part series that we're doing for Wales Tech Week, showcasing different R&D projects that we've got across the University of South Wales. For those of you that I've not met before, my name is Chris Wright and I'm the manager of USW Exchange. USW Exchange is our hub for creating connections between business and industry and the expertise that we've got here at the university. I've left my contact details and the contact details for Exchange in the chat bar, so if I can be of any assistance, do feel free to reach out to me. Before we start, a couple of housekeeping points then. Hopefully everybody's joined us using Google Chrome. We do tend to find that Chrome is the more stable web browser to join through. If you haven't, if you're running into any sort of connection issues, perhaps just copy and paste that link into Chrome and rejoin us over there in a minute. Likewise, if you're using a remote desktop connection or a VPN, we sometimes find that just disabling that for this session can be useful. Everyone's joined in listen-only mode, so you're able to ask questions to Hazel as we go through the session using the chat bar. If you've not found the chat bar yet, it's just under the purple tab in the bottom right-hand corner of your screen. I'm going to be sitting in the background monitoring the questions that are coming in, and we'll try and leave 5 or 10 minutes at the end to pick up any questions that we've not addressed throughout the presentation. We are recording the session, so if you have any connection problems or if you need to run off at any point, we will be circulating a watch back link within about 48 hours, so you've always got that opportunity there to catch up afterwards. Okay, so I'd like to introduce Dr. Hazel Hung, Business Development Manager for the Centre for Photonics Expertise at USW. Now, CPE, Centre for Photonics Expertise, aims to accelerate business growth by working together with industry, supporting the development of processes, products and systems. CPE is a pan-Wales project. It's developed and delivered by 4 Welsh universities and draws on leading academic capabilities, offering light-based technology solutions to businesses. So, Hazel, if you're there, I'm going to turn off my mic and hand over to you.
Okay, thank you, Chris. Can you hear me okay?
Yeah, absolutely.
Fantastic. Right, so yeah, thanks for the introduction and to USW Exchange as well for hosting this webinar during Wales Tech Week. This is actually the third and final webinar in our CPE Wales Tech Week webinar series. My colleagues from Wrexham Glyndŵr University and Bangor University presented their webinars yesterday, focusing on their state-of-the-art facilities and also their research background. So if anybody missed those, then they should be available on our CPE website over the next week. And yeah, so just to introduce myself, then I'm the CPE Business Development Manager, generally covering the South Wales region. My colleague, Carol Eccles, she covers generally the North Wales region, who's with us today. Hi, Carol. Yeah, so today I'll be presenting an overview of the CPE programme and how it can benefit businesses in Wales. So I'll give a general overview and then as well as focusing a little bit more on our offering within USW and presenting some case studies towards the second half of the talk. So next slide. So CPE is a Pan-Wales programme, as Chris said. It's funded by the European Regional Development Fund through the Welsh Government to support industry, university industry collaboration. We consist of 4 university partners. So we've got Wrexham Glyndŵr University, who are the lead partner, and they're based up at the Optic Technology Centre in St Asaph, Aberystwyth University, Bangor University and University of Wales. So the aim of the programme through these collaborations is to promote business and economic growth in the West Wales and the Valleys regions. This is perhaps a bit more of a challenge now than ever, but what we are trying to do is allow companies to explore development opportunities with CPE without impacting the daily needs of their business. So companies can think of CPE as a resource that's available to them to support R&D or product and process development within their organisation. And it's an easily accessible university resource, so projects can be started with us within a matter of a couple of weeks. So all we need to do is figure out what the project's going to be about and then get the paperwork signed off to start the project. And finally, projects are based on matched in contribution, so there's no cash cost to the company. So if we cost a project at £4,000 in CPE staff costs, then the company then has to match that cost in staff time. So, oh, have I done the right? Sorry, next slide. So who do we work with? So we've worked with 26 companies to date on 30 projects, and these companies are based around Wales, West Wales and Valleys region, which I'll define a bit later. And since lockdown, we have started 10 new projects, so it's great that companies are still able to engage with us even under the current circumstances. And I should say that since lockdown in March, we have all been working from home, but some of the teams are now starting to gain lab access, a couple of times a week, and we're starting to see within the universities that we should be able to gain lab access within the next month or so. So the company logos shown here are just a selection of the companies that we work with, and you can see that we do work with a variety of sectors. We've got a couple of companies in the medical sector with JR Biomedical and MC Diagnostics, scientific industry with Marks International and Steam Bio. We're also working with Corgi Socks, who make lovely hand-knitted socks in Ammanford, very popular with the royal family. Tection is based in the agricultural sector. And then, of course, we do work with companies in the photonics sector as well, with Global Laser, Neutral Light, and Lux TSI. So before we go on then, what is photonics? So photonics is a light-based technology that involves the generation, detection, manipulation of light. So by generation of light, that could be through lasers, LED bulbs, through the screen that you're looking at now. Detection could be through cameras, sensors, solar cells, and a good example of manipulation of light is in telecoms, so through phone and internet signals through fibre optic cables. So photonics is prevalent in our everyday lives. Most of us have a smartphone which is packed full of photonic technology. So you've got a screen on there that's made with it could be made with LEDs, OLED, it could be a backlit LED. There's also cameras on there. The new phones today have got multiple cameras on there, and there's infrared sensors as well. Now, according to the latest figures from the Photonic Leadership Group, the UK photonics output is 13.5 billion per year, which is equivalent to the UK pharmaceutical, fintech, or space industries. So it's a sizable industry. Now, these figures are for companies within the photonics industry itself. So, for example, semiconductor manufacturers, laser manufacturers, fiber optics, things like that. However, our focus at CPE isn't just in the photonics industry as such, but it's in photonics technologies, which is applicable across all industries like manufacturing, life sciences, the food industry. So the ones listed here are just a few examples, because photonics is applicable to a wide range of industries through things like sensing and measurement, vision systems, laser processing, spectroscopy, things like that. So on to our expertise then. Each of the university partners, CPE, specialises in their own area of photonics. So our lead partner, Wrexham Glyndŵr University at the Optics Centre, they specialise in precision optics and optical surface metrology, as well as thin film coatings. So the Optics Centre will be home to a thin film vacuum coating facility, which is going to be available for companies specifically working with CPE. That was actually wheeled into the building yesterday. So if you catch up on our social media at CPE, through CPE, then you'll be able to see a video of it being wheeled into the building. And just as a picture of it here, I don't know if you can see my mouse pointer, but there's a picture here with 1.35 meters, just to show the internal dimensions of the chamber. At Bangor University, they specialise in laser processing, so cutting, welding, and engraving. They've recently completed a project with a company called Diamond Centre Wales on laser engraving unique identification marks on diamonds for security and traceability. Aberystwyth University, they specialise in material science and photonics applied to chemistry. The image on the top right here shows the vacuum chamber for X-ray photoelectron spectroscopy, so XPS. which can be used to analyse the chemical composition of a sample. And this is, actually will be used on a project that was signed off this week with a company called Mod Naturals. And they want to know the chemical composition of clay particles in their clay mineral balm, which they hope to be used in the medical industry for open wound treatment. And then finally, USW. USW specialises in LEDs for lighting and illumination, laser systems design, optical modelling. And our co-academic lead is a professor of quality management, so he will be able to assist in this area as well as in quality engineering and continuous improvement process development. So how is all that relevant then to companies on the day-to-day running of the business? So quite often we might actually say to companies that they shouldn't dwell on the photonics aspects. So rather than think, how can photonics be applied within my organisation, they should ask the question, is there an engineering problem within my organisation, such as a bottleneck in production or quality control? And if the answer is yes, then there might be a solution that we can come up with within the CPE team. And the most common project areas are in quality control monitoring, waste reduction, production line improvements, prototype development, process testing and modelling and analysis. And these take the form of feasibility studies or developing a lab demonstrator or prototype right through to the implementation of a system. And this doesn't always involve novel cutting edge research. Sometimes it can be a case of finding a market solution that will work or work with a bit of modification. This is about combining the company's knowledge of their business with the knowledge within the CPE of photonics-based solutions. So here's just a quick example of a project. Just on the top right, there's a picture here. This is a company called Welsh Slate in Penrhyn Quarry near Bangor. And my colleague visited them to make an introduction to CPE, but also to talk about their company and any bottleneck areas they have. And they identified an area in product counting which involves manually counting the number of slates tightly packed in a pallet, like in this image. So this is where it's looking from the top down onto a pallet. And as you can imagine, it's quite time consuming to count these manually. So Bangor University worked together with Welsh Slate to develop an automated slate counting system based on a standard off-the-shelf camera. And this image shows a screenshot of the software program that they wrote at Bangor University, which reduced the product counting time down to a matter of seconds. And just finally, what to expect from projects. Projects are typically 3 months in duration, although there's not really maximum. There are things like delays due to the current circumstances. It can mean that a project has to be extended, but that's not a problem for us. The cost of a project is typically around the £3,000 to £5,000 mark in staff costs. Again, there's no real maximum or minimum to this as well. There's no limit to the number of projects as well. So projects can run in parallel if they're in 2 different areas, or one project can lead into another. So a feasibility study could then lead on to a lab demonstrator if the outcome of the feasibility study is that it's worth investing more time into. I'll be presenting some case studies in a second. Before I go on to that, I'm just going to talk about qualifying criteria. So to qualify to work with CPE, businesses must have an address within the West Wales in the Valleys region, and this is to show impact to this area. So this is shown by the map on the right, where the dark pink region is the West Wales and the Valleys. We can work with any size company, from a single entrepreneur to a large enterprise. Projects must aim to impact business and development. There's also shouldn't be any risk to job displacement, as the last thing we want to do is to take business away from local businesses, or take job away from somebody within that business. And finally, projects are based on matched in-kind contribution. As I've mentioned before, there's no cash cost to the company, but companies have to provide a match cost in staff time, which is evidenced by timesheets. So on to our first case study. This is a company called Global Laser. They are a designer and manufacturer of low-power laser diode modules, and they're located near the Brecon Beacons National Park. and have a factory covering 9,500 square foot as well. Their main applications for their laser diode modules are in machine vision and alignment, and also in the medical, and the scientific and defence sectors. So Global Laser worked together with USW, and the company requires many small parts such as laser mounts, holders, and these are all designed in-house, but then CNC machined or injection molded by an external supplier, which can be quite costly, particularly in low volumes. So the project with USW was a feasibility study to see if the company would benefit from investment in 3D printers, both in terms of functionality and cost. So the project began with a review of 3D printing technology, and then within USW we have access to a range of equipment from prototype development, a range of equipment for prototype development, including two types of 3D printer, FDM and SLA. So the FDM type stands for fused deposition modeling, and this is where the 3D printer uses a heated nozzle to selectively deposit polymer materials. SLA is stereolithography, which uses a vat of resin, which is selectively cured by a laser. So Global Laser parts were made on the FDM and SLA 3D printers. So on the picture, on the left-hand side of the picture, they're made by the SLA type, and on the right-hand side, the black parts are made from the FDM type. The company then checked and tested these 3D printed parts, and the recommendation then was for the company to purchase both types of 3D printer. So the FDM for the large, low accuracy parts, they're also lower in cost, and SLA for the small, high accuracy parts with accuracy down to 50 micron. And Global Laser actually since purchased an FDM printer, which is now part of their design and manufacturing process. An SLA type printer will be purchased later this year. And the company also estimates cost savings of about 5%, equating to approximately £8,000 per year. So this is a significant cost saving for them. An additional outcome of this project as a result of the university industry collaboration was an application for a CAFf studentship, which was granted, and the engineer from Global Laser started his PhD student earlier this month. The next case study is from a company called Mobilized Construction. Mobilized Construction is a provider of smart solutions for real-time road deterioration and data and analytics. So they are interested in real-time monitoring of road conditions to enable monitoring of road deterioration through potholes, bumps, and other hazards. And they've developed a smart sensor that can be easily installed into any vehicle, like buses and taxis. And they're working with local authorities in London and Cardiff. This is an accelerometer-based smart sensor about the size of a £5 note, as you can see from the picture here, which can pick up any bumps in the road as the vehicle drives over them. Actually, I should say that the CEO, Kevin Lee, was talking yesterday in the CMET webinar, as the company worked alongside CMET to develop this product. So you can watch this back, I think, on the USW Exchange website within the next couple of days. So then on to the CP project, and this was a collaboration, well, it's actually still ongoing. It's a collaboration with University of South Wales and Aberystwyth University. It started actually not long into lockdown, so working from home, and this involves the development of a photonics-based smart sensor for pothole detection. So the aim here is to improve on the accuracy of the current accelerometer-based system, as well as to identify other potential hazards due to road deterioration, such as faint road markings. And the project has just completed its first work package, which is reviewing prior art in a literature and a market overview. In addition, they'll also be testing a number of off-the-shelf camera systems, such as a dash cam, a GoPro, and a smart camera. So this got one of the camera images was taken here in this picture shown on the slide. I think they tested a range of different vehicles as well. So we'll also be looking into alternative photonic solutions like LiDAR and infrared sensing for pothole depth measurements. And the image and video processing analysis will be carried out by Mobilized Construction, as this is their area of expertise. So this is very much a collaboration from all sides. And the aim of the project then is to assess the viability of an image-based system for pothole detection and other hazards, and then also to identify potential routes to develop this demonstration unit into a fully packaged prototype. The next case study is a company called Neutralite. They are an LED manufacturer specialising in lighting and lighting solutions for the horticultural market. So their products will be optimised and tested with the support of a company called Digital Farming, who have access to 150,000 square foot to develop an indoor vertical farm. So this is more than just a lighting company. They are growing plants under artificial lighting, so they need to understand the daily needs of the plants from germination through to harvesting, and to be able to monitor conditions over a large area. And it's well known that plants respond well to blue and red light, as pictured by this graph here, which shows the response to chlorophyll. And you can quite often see horticultural lights with a purple sort of magenta hue. But actually plants do respond to a little bit of yellow as well. And if you add that to the red and the blue, then the light appears more white. And this is what Neutralite will be looking at, is white light for plant growth. So the collaboration with Neutralite is with USW and Wrexham Glyndŵr University. And this is to develop a prototype luminaire for horticultural lighting for growing small plants such as strawberries and microgreens. The project has two stages. The first is the optical modelling of a bespoke reflector design similar to the one pictured here, and also to find a design that illuminates the plants most efficiently and makes use of every single photon, so any light hitting the floor is just wasted energy. The second stage is to look at productionisation of the various components of the final design. And for a small company that is low on resources, then working with CPE is really great for them, especially as both sides have complementary photonics backgrounds. There's also potential here as well to apply for further funding. So for example, a smart partnership or smart expertise, which will then allow their business to grow. So the final case study is a company called Tection. They are a manufacturer of systems for disease management in the agricultural sector. They developed an image-based system which identifies parasite infection in livestock, such as sheep and cattle, using a process known as fecal egg counting. Essentially, this involves taking a sample of feces, preparing the sample, and then inspecting it under this microscope, which is shown by the black region in the photo. That's the microscope system. Next slide. So the CPE collaboration is with Aberystwyth University. The company wants to use an AI-based diagnostic platform to detect these parasite eggs. So the project with CPE is to look at the existing microscope system and then try to improve the optical resolution, which would then improve the accuracy of the image recognition. So the project involved evaluating the existing design and then making recommendations to improve the optical resolution for a new product design. The pictures on the right then show the images of parasite eggs before and after recommendations by CPE. So you can see that the improvements are significant. We actually managed to achieve a threefold improvement in the resolution, as well as identifying an opportunity to reduce costs of their image sensor and improve sample illumination. This project has been closed off now. This work's been completed. Again, this was during lockdown. And I believe that they are in discussions with Aberystwyth University for a second project now. So finally, in summary, collaborations with CPE work to develop or improve a new or existing product or process. Companies get a dedicated resource within CPE to work on their product and process. So this is at least one academic who works with the company throughout the whole duration of the project. And companies get to explore new ideas at low cost and at low risk as well. And finally, through CPE, companies have access to state-of-the-art university facilities. And that pretty much concludes my talk for today. Thank you for listening. My contact details are here on the right-hand side, together with my colleague who's based in North Wales. It's usually a north-south divide between the two of us, but in the current climate, regional boundaries are a little bit more blurred. So if anyone has any questions, then please use the chat facility here on Collaborate.
That's fab. Thanks, Hazel. That was perfectly timed as well, because we've got just a couple minutes left for Q&A. I definitely found that really useful to kind of spell out some of the practical applications for photonics. Because I think when I'd first heard of it, it was hard to kind of see where that would fit into business. But I think through those case studies, actually, there's loads of applications, isn't there, across that broad spectrum of expertise. And I think that's one of the benefits of the programme as well, isn't it, with it being sort of 4 institutions coming together on this. Organisations that want to tap into that support are basically able to harness 4 universities worth of expertise, depending on what their challenge is. That's great.
Yeah, that's exactly right. And it's not really tied to location as well. So we've got Bangor University coming down to South Wales, working with companies in the South region, and vice versa as well. So yeah, it's great that we cover such a broad area of photonics between the 4 universities.
I can see Jill's put a question in the chat bar asking about POWIS. Are there any plans for POWIS to be included in the scheme?
So yes, POWIS is, as you saw from the map, is out of region. So our project is funded until the end of next year. So if we were to extend to POWIS, it would have to be in a second second stage CPE project. So we would like to, like similar to the Astute programme and CMET, we would like to expand into East Wales as well, but we'll have to see after this.
And presumably, organisations looking to access expertise sooner, there are still other routes that they could drive that collaboration with universities.
Yeah, and I think it could be that if we can see that there's if we can demonstrate that there's impact to the West Wales and Valleys region, then potentially we could work with a company out of region, but we've not really done that yet. So we have had a couple of companies where they have small companies decided to move in region to be able to work with us and benefit that way. But it is difficult because we have to justify to our funding body, to WEFO, that we have to justify impact to the region.
Okay. Just a couple of questions that I had as we were going through. Is there a sort of rule of thumb in terms of how quickly projects could be mobilised? If there are any businesses that are listening thinking, this is fantastic, I want to access it, how quickly can I get going?
Yeah, I think the best thing to do is just to drop us a line and just to have a little chat about their company and any ideas that they might have. And so what usually happens is that the BDM team would chat to the company, talk about any sort of bottleneck areas, or they might think, oh, actually, we've got a product counting that's similar to Welsh Slate that we could use. And what we do is we take that back to the team and we discuss it, have a brainstorming session internally, and then we go back to the company to discuss it further. So the thing is just to drop us a line. We're happy to chat.
Great. Okay, well, I can't see any other questions coming into the chat bar, so I think we'll wrap up there. So thank you, Hazel, for your presentation. It's really good, really practical examples of how this technology can be implemented. As I say, we have recorded the session, so if anybody wants to kind of recap on this, then we'll be putting this recording around in the next 48 hours. You'll get a copy of it through to your inbox, but we'll also put it up on our web pages as well. And thank you to everyone for joining us this afternoon. Obviously, you've got Hazel's details there on the slide. My details are further up in the chat bar. If you'd like to get in touch, just drop us a line. Take care, everyone.
Thanks, Chris, and thanks everyone for listening. Thank you.